Welcome to a set of lessons on set theory, pun intended. In this lesson, we will introduce sets and learn some of the basic notation for describing sets, as well as the objects inside of a set. A set is essentially a collection of objects. Sets may collect together objects that share similar features, like the four animals that we have here, but they don't have to. Sets are important for us in early development as they lead us to the idea of numbers and counting. Take a moment to think about how we might describe this set in words. As we progress in mathematics, sets will become more and more abstract. For us, there will be many instances in which we will deal with sets of numbers. In higher mathematics, we even work with sets of functions. Take a look at the numbers on this slide. What do you notice? Would we be able to use a particular property of these numbers to help us discuss the set using words? So let's go back. How might we describe this set? Well, this set has four distinct animals. So we might say this is the set of four animals: panda, monkey, dog, and elephant. Since there are so few objects in this set, we could even list them like this. To denote a set, we typically use capital letters and squiggly braces. So here I've used the letter A to describe our set of four animals. What about this set? Did you happen to notice any pattern within these numbers? What if I rewrite the numbers like this? Maybe you notice that each of these numbers that we started with is a perfect square. In fact, this is the set of the first 10 perfect square numbers. Now, there are quite a few objects in this particular set, and while we could write them all out, sometimes it's easier to use algebraic notation to help us out. This is called set builder notation, and it's read: B is the set of square numbers where x ranges from 1 to 10, and x is a whole number. In summary, we have seen three different ways to refer to sets. The first is to describe the set using words. Often this is used as a way to ease into the more algebraic ways to represent a set. Using words can be helpful when trying to highlight a property of the objects in the set, as using more algebraic notations might lose some of this information in translation. A second way to describe a set is using a list. If we have relatively few objects that don't share a particular property, this might be the easiest method to use. Finally, we can use what's called set builder notation, where we locate an important property of all of the objects in the set and try to describe it algebraically. As we progress through mathematics, set builder notation becomes more and more common. So far, we have only seen sets that contain objects, so you may wonder if a set can contain no objects. The answer is yes. We call this special set the empty set, and we can write it in two different ways. The first way is to simply write down the squiggle braces and just not put any objects inside of the braces. The second way we can denote the empty set is by drawing a 0 and putting a slash through it. One last thing that we might want to do is refer to a particular object in the set. Each object in a set is called an element. So for our set of four animals, it has four elements: panda, monkey, dog, and elephant. Using words, we could say monkey is an element of the set, or crocodile is not an element of the set. Let's look at the notation for our set B of perfect square numbers. If we don't want to use words to refer to an object, there are special symbols that we can use instead. For example, a rounded E can be used to show that an object is in the set. 36 is an element of B. Which statement over here on the right side do you think is true? Both are actually true. 64 is an element of the set B, so the statement on the bottom is truthful. Notice that the number 65 is not inside of B. And so you may have guessed that that's what that E with the slash through it means. So if we want to show that an element is not in a set, we can take that rounded E and put a slash through it. It's kind of like working with equals and not equals.
All right, my little epsilons, stay positive.